thermal engineering, we are considering whatever system, it is in the thermodynamic equilibrium. Okay, what is the meaning of equilibrium? Equilibrium is the condition of the system is in the balanced state, in the balanced way. Okay, it should not have unbalanced forces or unbalanced temperature like that. The balanced condition we can call it as equilibrium. So the system is in equilibrium. So the system is in balanced condition. So thermodynamic equilibrium is, it should has thermal equilibrium and chemical equilibrium and mechanical equilibrium. Okay. Thermal equilibrium means there will be no temperature difference within the system or between system and surroundings. Whatever temperature here inside this, the temperature is same as surroundings. Okay, and if you are taking 2 points here, 1 2 3, here also temperature is same. If you are taking 2 points, one is here first position, second point is here, the temperature at one point and second point is also same. So the meaning is thermal equilibrium is the system has no temperature difference within the system or between the system and surroundings. Okay, why we are considering like this? For example, in this system I am taking one internal combustion engine. Okay, automobile vehicle engine I am taking. This is, we are studying, this is our system. Okay, so because of combustion of fuel inside this engine, okay, I am taking, this is the engine. Engine temperature is more. Okay, the surrounding temperature is less, and here temperature difference is there. Is it in equilibrium? It is not in equilibrium, because here the temperature is more, here the temperature is less. So according to thermal equilibrium, there will be no temperature difference between system and surroundings. So for keeping this engine in equilibrium, what we are doing, for big engines, for big automobile vehicles, for heavy duty engines, we are cooling this engine with some fluid or some coolant we are passing around the cylinder of the engine. Why we are passing, why we are cooling this engine means, we are trying to keep the surrounding temperature of this engine. Otherwise, whatever material we are using, cylinder we are using for the combustion process, the material will burn easily. Okay, we are supplying air or coolant or cool air for getting this temperature of this cylinder with the surrounding same temperature as the surrounding. We are trying to keep in equilibrium of this engine. Okay, so the main aim is it should have thermal equilibrium. Whatever objects, whatever engines, whatever we are considering here, turbines or boilers, it should have thermal equilibrium. Another easy example I will tell. I am taking one hot rod here in the system. Okay, so compared to surrounding temperature is some T temperature. This is more high temperature compared to surrounding temperature. After some time, this will also it will getting cool because of air surrounding in the atmosphere. It is also getting cool. Now after some time, this temperature is also T. Okay, so this is in thermal equilibrium with the surroundings. Okay, so this is called there is no temperature difference between system and surroundings or within the system also. Whatever rods we are taking, it is also at the same temperature. So that's why each and every whatever thing we are taking, okay, it is getting heat, but we are trying to cool it for keeping the surrounding temperature. It should be in the balanced condition. Otherwise, whatever objects we are considering here, cylinders, pistons, all will burn with the high temperature. So each and every engine should be in equilibrium. Thermal equilibrium means no temperature difference. And similarly, chemical, it should have chemical equilibrium. It should not have, no chemical reaction should take place between system and surroundings. The next one, in chemical equilibrium, there will be no chemical reaction within the system or between system and surroundings. Okay, now here I will take one example. In one system, I am taking one container, iron container like this. Okay, so iron has rusting property. It will easily get rusting on the surface because of oxygen in the surroundings. Okay, what we are doing for equilibrium in order to avoid the rusting, what we are doing, we are coating this cylinder or object with some paints. Okay, so after painting it is in equilibrium. There will be no chemical reaction between system and surroundings. This is our system, this container is our system. Okay, so I'm taking, this is the system, this is the surrounding. Without coating it has chemical reaction, so we can say it is not in chemical equilibrium. Whatever objects we are using in engines, steam turbines, those should be in chemical equilibrium. Okay, so we are avoiding the unbalanced chemical reactions by painting or coating with on the surface of the taken object. And similarly, third one, the system and surroundings should have mechanical equilibrium, means no unbalanced forces should be there. Now I am taking, in this system I am taking one system here, I am keeping this object here. Okay, this object, it is in the balanced state. Okay, so there are no unbalanced forces. What I am doing is I am giving one force this side, it is moving in this direction, it has unbalanced force. So whatever force here I am applying, we have to apply the same force in the opposite direction, so that it is in the system at the equilibrium condition. Okay, so between system and surroundings there will be no unbalanced forces. Okay, it is called mechanical equilibrium. Now in all in thermodynamics or thermal engineering, whatever systems we are considering, those should be follow thermal equilibrium, chemical equilibrium and mechanical equilibrium. At the time only the engines, turbines or whatever vehicles we are taking, those are in the balanced condition. Or